Hey guys, in this video I'm going to walk you through how to answer questions for individual assignment regarding forecasting. These problems are related to time series analysis technique. Time series analysis is based on the idea that the data relating past demand can be used to predict future demand. So time series analysis is basically to forecast demand based on historical data. So if you don't have historical data, you cannot use this method. Question 1 is about forecasting the number of complaints received in a department store for the first 6 months of operation. This question asks you to use 3-month moving average method to forecast for complaints in May. The idea here is to simply calculate the average demand over the most recent period. This is a very useful tool when the demand is not changing rapidly, showing the seasonality. In this exercise, you already know the actual complaints from January to June. 3 month moving average is to simply take the average of the last 3 months of actual demand. For 3 month moving average, we need to start with April. We use those numbers to predict for every month, April through June. All you need to do here is to add up the complaints for the 3 prior months and then divide by 3, which means to take the average of 3 prior months. So you will get April forecast 59.3. You can use average function in Excel shown here in order to forecast the number of complaints in May. You can just drag it down to June. May forecast will be based on the actual complaints in February through April. We will get a forecast for May 78. Similarly, June forecast will be based on the complaints data from March through May. Our forecast for June will be 103 and so on. And you can continue similar method to forecast for July through December in that particular year. Let's move on to next question. Next question is that based on the historical data, your manager decides to use the weighted 3-month moving average technique for forecasting demand for a period of time. Weighted moving average is very similar to simple moving average. When it comes to weighted moving average, what you are doing is different data values will carry with themselves different weights. Here is the formula associated with that. As you can see, weighted moving average formula here. Basic formula for weighted moving average method have a lot of subscript. W sub 1 is weight to be given to the actual demand for the period T minus 1, which is zero point 0.4 here in this question. W sub 2 is weight to be given to the actual demand for the period T minus 2, which is zero point 0.3. W sub 3 is weight to be given to the actual occurrence for the period T minus 3, which is zero point 0.3. So W sub n is weight to be given to the actual demand for the period T minus n. The sum of the weights must be equal to 1 and represent the number of the prior periods of actual demand used to forecast for the next period. So weighted moving average allows us to assign unequal rating of demand in prior time period for forecast future demand. In this method, one of the important things is to assign weights on demand in specific period. The simplest approach is to assign weights based on previous experience or trial and error. Also, the recent past data can be the best indicator to forecast the future demand. So the most recent information always gets the highest weight, and the information farthest into the past will get the lowest weight. Again, your weights all have to add up to 1. And if the data have the seasonality, weights should be reflected properly. We will use a weighted moving average method with the weights of 40% of the actual demand for most recent month, at 30% of 2 months ago and 30% of 3 months ago. Typically, you can save to assume the highest weight is assigned to the most recent actual demand, second highest weight is assigned to the second most recent actual demand, and so on. Because this method assumes that the recent prior demand is often the best indicator for the future. I already added a column to our data table to indicate the weights for the 3 actual demand figures that we will use it creating our weighted moving average. Using the weights and the actual demand figures from month 1 through 3 and plug them into our basic equation. We can come up with the forecast for month 4 is equal to zero point 0.4 our weights, our first weight times 57 actual demand plus zero point 0.3 our second weight times 55 actual demand in month 2 plus 0.3, our third rates times 52 actual demand in month 1. The forecast for the month 4 using weighted moving average is 54.9. Similarly, to forecast for the months 5 through 12, you can just drag it down after fixing each weight in front of column and row and column and row and column and row. Now you can move on to 10 week to check it out. You can just come up with the forecast for month 10 is equal to 0.4 our first weight times 77 actual demand in month 9 plus 0.3 the second weight times 67 actual demand in month 8 plus 0.3 the third weight times 66 actual demand in month 7. Finally, we got the predicted demand in month 10, 70.7. Let's move on to next question. For the next question, we need to forecast the April using simple exponential smoothing, and then calculate the mean absolute deviation for all the forecasts. Exponential smoothing is widely used in ordering inventory in retail firms and wholesale companies and service agencies. In this method, we need only 3 pieces of information to forecast the future. Those are the most recent forecast, the actual demand, the accord for that forecast, and smoothing constant alpha or the desired response rate, which is zero point 0.4 in this case. This smoothing constant determines the level of smoothing and the speed of reaction to differences between forecast and actual demand. The value for the constant alpha is determined both by the nature of the product and by the manager's sense of what constitutes a good response rate. The formula for simple exponential smoothing is shown here, where f sub t is the exponential smoothed forecast for period t, f sub t minus 1 is the exponential smoothed forecast for the prior period t minus 1, a sub t minus 1 is the actual demand seen in the prior period t minus 1, and alpha is the desired response rate, also known as a smoothing constant. In this question, we assume that the long-run demand for the product is relatively unstable, and a smoothing constant 0.4 is used to estimate February to June. To get initial forecast, the starting point, we can easily get it from the actual demand for January. From there forward, we will apply the exponential smoothing model. Essentially, what's going on in an exponential smoothing technique is that the forecast for one period is equal to the forecast for prior period, adjusted either up or down based on the error of that forecast in the prior period. So our forecast for February will equal the forecast from January 75 plus zero point 0.4 smoothing constant times the forecast error is to find its actual demand in January 95 minus what was forecast for January 75. We do the math error is 20 here. We get a forecast for February 83, higher than the forecast for January since the actual demand is higher than expected in January. To continue, we can just drag it down after fixing the smoothing constant by adding the dollar sign in front of a column and row. And then we can check our forecast for March, although equal the forecast from February, 83 plus alpha zero point 0.4 times the forecast error in the prior period, February. Forecasting error is to find its actual demand in February 93 minus what was forecast for February 83. We do the math, we get a forecast for March 87. Essentially, we have taken February forecast and adjusted higher since the forecast in February was lower than the actual demand in February. Similarly, our forecast for April would equal the forecast from March 87 plus zero point 0.4 times the forecast error in prior period March. Forecast error is to find its actual demand in March 102 minus what was forecast for March 87. We get a forecast for April 93. Essentially, we have taken March forecast and adjusted higher since the forecast in March was still lower than the actual demand in March. Next, we have to measure mean absolute deviation. Typically, there are 3 techniques to measure forecast errors: mean absolute deviation, mean absolute percent error, and tracking signal. In this question, we use the mean absolute deviation, which compares the actual demand and forecasted value. What you are doing is you need to compute the absolute deviation of each month. Absolute deviation is defined as the absolute value of the difference between actual demand in month and forecast value in that particular month. So mean absolute deviation is sum of absolute value of forecasted errors divided by the number of forecasts, which means taking average of all your forecast errors. In this exercise, the absolute deviation of first month is defined as the absolute value of actual demand in first month, 95, minus the forecasted demand in January, 75. For this, we have to use the absolute value function in Excel. Similarly, to continue the following the same methodology in remaining months, just you need to drag it down to June for calculating the absolute value of the actual demand minus the forecasted demand in each month respectively. Now we can calculate the mean absolute deviation, which is the average of all the absolute deviation for exponential smoothing. So average of all your forecasted error. So the sum of the absolute deviation over the 6 months, 17, using average function. Let's move on to next question.